What's up, math peeps? We are back with another one, and this time we are solving exponential equations. Exponential equations. Exponential equations. Alright? And so, an exponential equation is simply an equation. An equation whose exponent contains the variable. Alright? Now, before you jump into these exponential equations, and before you jump into these exponential equations and everything, you need to make sure you have these laws of exponents down. Alright? So we're going to run through these laws of exponents right quick. Laws of exponents. Everybody need to have these down so it'll make your life flow much smoother. First one is when you multiply two things with the same base, the product rule for exponents. So we have a to the m times a to the n. You keep the base, add the exponents. Quotient rule for exponents. A to the m divided by a to the n. Going along the same lines, you will subtract the exponents. Alright? Then if you have a product to power, let's say you have two different bases, and they're raised to some exponent m, you will distribute that exponent to both of the factors in the parenthesis. Or if it's more than two factors in the parenthesis, as long as it's products all throughout, you distribute that exponent all the way throughout. Alright? And then, let's see, we have negative exponent. A to the negative m. Alright, that negative sign says take the reciprocal of the base. The base is a, so we're going to take the reciprocal of the base. We're done what the negative sign told us to do. Keep the exponent on our side. That equals 1 to the m over a to the m, which is equal to 1 over a to the m. I feel like that one needs additional breaking down. That's why I went through it. I didn't go and do the quotient to power though. A over b raised to the m, that is equal to a to the m over b to the m. Alright? And then you have a raised to the 0 power. Any number excluding 0 raised to the 0 power is 1. Alright, let me toss this a in parentheses because I want you to just make sure you're putting the whole number inside the parentheses, because if that was negative 5 raised to the 0, you need that negative sign inside that parentheses. Alright, note that in this case, a and b, those bases are not equal to 0. Alright? Alright. And you're going to have to know how to manipulate these things, man. You're going to have to know how to maneuver them, move them around. Alright? And then let's toss in this little corollary right here. Let's say if a to the m equals a to the n, the bases are the same. The only way that equal sign can hold true is m and n equal each other. Alright? We're going to be using that a lot to solve exponential equations. All right, let's move up a little taste. So the first example, let's start off with a little kitty walk example. Let's say we have 3 to the x equals 3 squared. First question you ask yourself, are the bases the same? The bases are the same. So then, according to this corollary above, this problem is solved. Since the bases are the same, you set the exponents equal to each other and solve for the variable. Alright, we'll do the same problem. I'm just going to change it up a little taste. 3 to the x equals 9. Now, are your bases the same? No. But can you rewrite one of those bases to look like the other? Alright, using some exponents. Alright, 9 can be rewritten as base 3. If we rewrite that as 3x is equal to 3 squared, because 9 is 3 squared, and then we have our solution, x equals 2. Once you get your bases the same, you set the exponents equal to each other, and voila, done. Alright, let's amp this thing up a little bit because y'all are some highly intelligent individuals. Let's say we have 16 raised to the x minus 2 equal to, let's say 64 raised to the I don't know, let's say x. Alright, clearly the bases are not the same, right? Alright, but let's look at those bases. What are the bases? 16 and 64. Can those bases be written using a common base? If you say, yeah, it's because you're so intelligent, okay? The common base is 4. 16 is 4 squared raised to the x minus 2 equals 64 is 4 cubed raised to the x power. Now the reason I wanted you to see that, because now you got to recall some of these laws of exponents. We have, did I not put that up there? No, I did not. Alright, before we finish this, we need power to a power in our laws of exponents. Power to a power, if you have a to the m raised to the n, you multiply exponents. Alright, here we have power to a power. So we have 4 to the second times x minus 2 equals 4 to the 3x. Power to a power, we multiply the exponents. Now by the corollary, the bases are the same. The bases are 4. So since the bases are 4, we set the exponents equal to each other and get to work. So we have 2 times x minus 2 equal 3x. We're not throwing anything away. Someone asked at one time, so you just throw the 4's away? No. By the corollary, once the bases are equal, we can set the exponents equal to each other. And we just start solving some stuff. We have 2x minus 4 equal 3x. Get the variable on one side, constants on the other. We have negative 4 is equal to x. Whenever we subtract 2x from each side, bada boom, we have our final answer. Alright. And that's how you do these solving exponential equations. All right. Now I need to introduce to you exponential functions. All right. We're not going to go into the detail about solving an exponential function, but I do want you to be able to view and identify exponential function. All right. Exponential function is f of x equals c a to the x, where c is the initial value. All right. Now let's say uh, you can either have a growth function, and the graph for your growth function would increase rapidly, like so. Or you can have a decay exponential function. And your decay function, again, decreasing rapidly. Alright, so I just wanted to introduce that information for upcoming in the next video. And yo, let's just be ready to knock out some exponentials. It might be in the next video, might not. Anyways, math people, we are out.